Picture this, a river of fire, not on Earth, but flowing from the very heart of our sun. Not flames as we know them, but something far stranger. A silent storm of invisible particles racing toward us at nearly 1,000,000 miles per hour. This is the solar wind, the sun's breath, sweeping through the solar system, touching everything in its path. What if I told you that right now, as you listen, countless particles from this cosmic river are passing through you? They're the same particles that paint the sky with dancing auroras, that whisper secrets about the birth of our solar system, and that could one day power humanity's journey to the stars. But how does this hidden river begin its journey? What strange forces hurl it across the emptiness of space? And why, after centuries of watching its effects, are we still unraveling its mysteries? Tonight, let's drift into the story of this invisible tide, the gentle yet powerful force that connects us all to our life-giving star. Close your eyes and imagine riding those particles as they spiral outward from the sun's fiery crown, past the planets, beyond the edge of our cosmic neighborhood. Where will your mind wander as we follow this stream of starlight together? And as you float among these questions, tell me, where are you listening from tonight, and what does the sky look like above you? Now let's trace this cosmic river back to its source, the sun's fiery crown. Imagine standing at the edge of our star, where the atmosphere stretches far beyond what your eyes can see. This is the corona, a halo of superheated gas, glowing with temperatures hotter than the sun's surface itself, so intense it defies common sense. Here, atoms are torn apart into a swirling soup of charged particles, electrons and protons, moving so fast they can't be contained. The sun's gravity, powerful enough to hold entire planets in orbit, isn't strong enough to keep them trapped. Like steam rising from a boiling kettle, these particles break free, streaming outward in all directions. But this isn't just heat doing the work. Magnetic fields twist and snap like rubber bands, flinging particles into space with unimaginable force. Picture a cosmic slingshot, launching fragments of the sun's own heart across the solar system. This is how the solar wind begins its endless journey, a river born from fire and magnetism, carrying the story of our star to worlds beyond. And as these particles rush past you now, remember, each one began its voyage in a place where even light bends, where the rules of physics, as we know them, are rewritten by the sun's fierce embrace. Now, let's step into the sun's invisible playground, the realm of its magnetic fields. Picture a vast, tangled web of energy, stretching far beyond the sun's surface, shaping everything around it. These magnetic fields aren't static. They twist, stretch, and snap like overstretched rubber bands, releasing bursts of energy that send particles hurtling into space. When two magnetic field lines cross or reconnect, it's like a cosmic short circuit, unleashing enough power to fling charged particles outward at speeds that defy imagination. The sun's surface is a constant dance of chaos and creation, where loops of magnetic energy rise and collapse, driving the solar wind's unpredictable flow. Some of these eruptions are so violent, they can launch material across millions of miles in just hours. And just like a storm on Earth, no two magnetic dances are ever the same. Each one leaves its own unique mark on the solar wind's journey. This ever-shifting magnetic ballet is what gives the solar wind its rhythm, a pulse of energy that echoes throughout the solar system. But here's something fascinating: the solar wind isn't just one uniform stream. It actually comes in two distinct flavors, each with its own personality. The first is the fast solar wind, racing through space at speeds of up to 800 kilometers per second. This speedy version bursts out from regions called coronal holes, dark, cooler patches in the sun's corona, where magnetic fields stretch open like unlocked doors, letting particles escape easily. Then there's the slow solar wind, moving at a more leisurely pace of 300 to 400 kilometers per second. This one originates closer to the sun's equator, where tangled magnetic fields trap particles longer before finally releasing them. Now, imagine these two winds traveling side by side through the solar system. When the fast wind catches up to the slower one, it creates a kind of cosmic traffic jam, a turbulent boundary where particles pile up and magnetic fields get twisted. These collisions can spark ripples and shocks, like waves crashing together in an ocean of charged particles. And just like weather patterns on Earth, these interactions shape space weather, influencing everything from auroras to satellite communications. So while they may seem like simple streams of particles, the fast and slow solar winds are anything but ordinary. They are dynamic forces, constantly reshaping the space around us. Now, let's turn our attention to a mission that's brought us closer to the sun than ever before: NASA, a Parker Solar Probe. This incredible spacecraft is humanity's first attempt to literally touch the sun, diving into the solar corona to unlock secrets of the solar wind that have puzzled scientists for decades. Launched in 2018, the probe is designed to withstand blistering temperatures and intense radiation, flying closer to the sun than any previous mission. What has it discovered so far? For one, the Parker Solar Probe has revealed how the solar wind accelerates as it moves away from the sun. Instead of slowing down, as some theories predicted, the particles actually speed up, defying expectations. The probe has also detected strange S-shaped kinks in the solar wind's magnetic field, nicknamed switchbacks. These sudden reversals in the magnetic field's direction are like cosmic zigzags, and scientists are still working to understand what causes them. Some think these switchbacks might play a key role in heating the corona and energizing the solar wind. Every time the probe loops closer to the sun, it sends back data that reshapes our understanding of our star's influence. It's like having a front row seat to the sun's most dynamic processes, giving us clues about everything from space, weather to the fundamental physics of plasmas. The Parker Solar Probe isn't just rewriting textbooks, it's helping us predict how solar activity could impact Earth in the future. And with each orbit, it brings us one step closer to solving the mysteries of the solar wind. While the Parker Solar Probe unravels the secrets of the solar wind at its source, let's shift our gaze closer to home, to Earth's own invisible shield. Our planet is constantly under siege by the sun's charged particles, but we're far from defenseless. Earth's magnetosphere, a powerful magnetic field generated by our planet's molten core, acts like an enormous force field, bending and redirecting the solar wind around us. Picture it as an endless cosmic dance, where the magnetosphere pushes and twists against the relentless stream of particles, keeping most of them at bay. Without this protective barrier, life as we know it wouldn't survive. The solar wind carries enough energy to strip away our atmosphere over time, much like what happened to Mars, which lost its magnetic shield billions of years ago. But Earth's magnetosphere doesn't just block the solar wind, it reshapes it. The particles pile up on the side facing the sun, compressing the magnetic field, while on the night side, it stretches out into a long tail, like a windsock caught in a storm. Even so, some particles manage to slip through, especially near the poles where the magnetic field lines funnel them downward. These intruders collide with gases in our atmosphere, sparking the dazzling light shows we call auroras. But for the most part, the magnetosphere holds the line, a silent guardian against the sun's fiery breath. It's a delicate balance, one that has sheltered life for billions of years, allowing oceans to flow and forests to grow under the protection of an invisible shield we rarely even think about. Yet this shield isn't impenetrable. During powerful solar storms, the solar wind can overwhelm our defenses, triggering geomagnetic disturbances that disrupt satellites, power grids, and communication systems. It's a reminder of how much we rely on this unseen barrier, and how vulnerable we'd be without it. So the next time you gaze at the night sky, remember the quiet battle raging overhead, where Earth's magnetic field stands guard against the endless stream of particles from our star. Now, let's turn our attention to one of the most breathtaking side effects of this cosmic battle, the auroras. When those sneaky solar wind particles slip past Earth's magnetic shield near the poles, they don't just vanish. Instead, they collide with oxygen and nitrogen in our upper atmosphere, and that's when the real magic happens. These collisions release bursts of energy in the form of light, painting the sky with shimmering curtains of green, pink, purple, and even red. The northern and southern lights aren't just random splashes of color. The hues depend on which gas the particles hit and how high up the collisions occur. Oxygen glows green or red, while nitrogen produces blues and purples, and the shapes, those rippling waves and dancing ribbons, are sculpted by Earth's magnetic field, guiding the particles into mesmerizing patterns. It's like the sky itself is putting on a silent, celestial ballet, choreographed by invisible forces. For centuries, people have been captivated by these displays, weaving myths around them, from Viking legends of Valkyrie armor to indigenous stories of spirits dancing in the heavens. Today, we know the science behind them, but that doesn't make the experience any less awe-inspiring. Standing under an aurora, you're not just seeing light. You're witnessing the solar wind itself, transformed into something beautiful, a reminder that even the sun's most chaotic energy can create wonder. And here's something fascinating. Auroras aren't unique to Earth. Other planets with magnetic fields, like Jupiter and Saturn, have their own dazzling light shows, though their colors and intensity differ based on their atmospheres. But for us, the auroras are a rare glimpse into the invisible forces that shape our world, a nightly reminder of the delicate balance between the sun's fury and Earth's quiet resilience. But while the auroras paint the sky with beauty, the solar wind can also unleash far more destructive forces. Let's talk about solar storms, those moments when the sun's temper flares and the solar wind transforms from a gentle breeze into a raging tempest. During a solar storm, the sun ejects massive bursts of charged particles at incredible speeds, sometimes over 1,000,000 miles per hour. When these particles slam into Earth's magnetic field, the results can be dramatic. Satellites orbiting our planet can be knocked offline, disrupting GPS signals, television broadcasts, and even military communications. Power grids on the ground aren't safe either. Intense solar storms can induce powerful electrical currents in power lines, causing blackouts that last for hours or even days. One of the most infamous examples happened in 1859, known as the Carrington event. Back then, telegraph systems, the cutting-edge technology of the day, went haywire. Operators reported sparks flying from their equipment, and some telegraph lines caught fire. Auroras were seen as far south as Cuba and Hawaii, so bright that people could read newspapers by their glow at midnight. If a storm like that happened today, experts estimate it could cause trillions of dollars in damage worldwide, knocking out critical infrastructure for months. The scary part, we're not immune to these events. In 1989, a much smaller solar storm left 6 million people in Quebec without power for 9 hours. And in 2012, a Carrington-level storm narrowly missed Earth. Scientists only realized it after analyzing satellite data. So why don't we hear about solar storms more often? Thankfully, our planet's magnetic field does an incredible job shielding us from the worst effects. But as our reliance on technology grows, so does our vulnerability. That's why space agencies like NASA and NOAA constantly monitor the sun, giving us early warnings to prepare. Because while the solar wind usually whispers, when it roars, the entire planet feels it. Now, let's zoom out and picture something even bigger, the heliosphere. Imagine it as a giant, invisible bubble surrounding our entire solar system, created by the solar wind as it streams outward from the sun. This bubble isn't just empty space, it's filled with charged particles and magnetic fields, all pushing against the stuff between stars, known as the interstellar medium. Think of the heliosphere like a cosmic force field. Just as Earth's magnetic field protects us from harmful solar radiation, the heliosphere shields every planet, moon, and asteroid in our solar system from the harsher radiation lurking in interstellar space. Without it, high-energy particles from distant supernovas and other cosmic events would bombard us, making space travel far more dangerous and potentially even affecting life on Earth. But here's the fascinating part. This bubble isn't static. It's constantly changing shape as the solar wind ebbs and flows with the sun's activity. When the sun is more active, the heliosphere expands, pushing farther into interstellar space. During quieter periods, it contracts, like a balloon slowly losing air. Scientists study the edges of this bubble using spacecraft, like Voyager 1 and 2, which have ventured beyond the planets into this mysterious frontier. What they've found is a turbulent boundary where the solar wind finally loses its strength, colliding with the interstellar medium in a chaotic dance of particles and energy. So next time you look up at the night sky, Remember, we're all living inside this incredible, invisible shield, a testament to the sun's far-reaching influence. And as we'll soon see, this bubble isn't just a barrier. It's also a gateway to understanding even deeper mysteries of our cosmic neighborhood. Now, let's journey to the very edge of our solar system, where the solar wind's journey comes to an end. This is the Heliopause, the invisible boundary where the sun's influence finally gives way to the vast expanse of interstellar space. Picture it like the shoreline of a cosmic ocean, where the waves of solar wind crash against the currents of the interstellar medium, creating a turbulent and mysterious frontier. Voyager 1 and 2, humanity's farthest reaching spacecraft, have given us our first close-up look at this boundary. As they crossed the Heliopause, they detected something surprising. The solar wind doesn't just fade quietly into the background. Instead, it collides with interstellar material in a chaotic swirl of particles and magnetic fields, like two weather fronts clashing in a storm. What makes this region so intriguing are the unanswered questions it holds. For instance, why does the Heliopause seem to ripple and shift, as if it's breathing? And how do particles from the solar wind mix with those from interstellar space, creating a strange hybrid zone scientists are still trying to decode? Some theories suggest that the shape of the heliosphere itself might resemble a deflating balloon, pushed unevenly by the flow of the interstellar medium. Others propose that magnetic fields from beyond our solar system could be sculpting this boundary in ways we don't yet understand. One thing is certain: the edge of our solar system is anything but empty. It's a dynamic, ever-changing region where the sun's reach finally meets the broader galaxy, offering clues about how stars interact with the space around them. And as Voyager 1 and 2 continue their lonely voyages deeper into the unknown, they're sending back data that could rewrite our understanding of home. So while we might think of the solar system as ending at Pluto or the Kuiper belt, the truth is far more fascinating. The solar wind stretches our neighborhood's boundaries much farther than we once imagined, and the mysteries waiting at the edge are just beginning to unfold. Now, let's turn our attention to one of the most beautiful interactions between the solar wind and celestial visitors, comets. These icy wanderers from the outer solar system put on a spectacular show when they swing close to the sun, and it's the solar wind that helps create their stunning tails. As a comet approaches the sun, heat causes its frozen gases to vaporize, releasing dust and gas into space. But it's the solar wind that sculpts this material into the iconic tails we see. The charged particles streaming from the sun push against the comet's released gas, forming a straight, glowing ion tail that always points directly away from the sun, no matter which way the comet is moving. Meanwhile, sunlight itself pushes the looser dust particles into a broader, curved tail. Take Halley's Comet, for example, one of the most famous comets in history. Every 76 years, as it nears the sun, it develops two distinct tails. The ion tail, made of charged particles, shines with a faint blue glow as it's swept back by the solar wind. The dust tail, reflecting sunlight, appears white or yellowish and curves gently behind the comet's path. This celestial dance isn't just beautiful, it's also a clue to the solar wind's power. Even though the solar wind is incredibly thin, its constant flow is strong enough to shape entire comets, stretching their tails across millions of miles. And because the ion tail always points away from the sun, it acts like a cosmic windsock, showing us the direction of the solar wind's flow in real time. Next time you see an image of a comet with its twin tails streaming behind it, remember, you're not just looking at a frozen relic from the solar system's past. You're witnessing the invisible hand of the solar wind, shaping the cosmos one particle at a time. Now, let's take a closer look at what the solar wind is actually made of. Picture it like a cosmic river, but instead of water, it's flowing with tiny particles, mostly hydrogen, the simplest and lightest element in the universe. These hydrogen particles come in the form of protons and electrons, stripped apart by the sun's intense heat. But that's not all. Mixed in with this stream are traces of helium, along with even heavier ions like oxygen, carbon, and iron. Scientists study these particles like detectives, piecing together clues about the sun's inner workings. By capturing and analyzing solar wind samples, they can learn about the sun's composition without ever touching its fiery surface. Spacecraft like NASA's Advanced Composition Explorer have been doing just that for decades, collecting these particles as they zip past Earth. What's fascinating is how this mix of elements tells a story. The abundance of hydrogen and helium reflects the sun's origins, mostly leftover material from the early universe, but the heavier ions hint at deeper processes, like nuclear fusion in the sun's core, where atoms collide and transform, releasing energy that eventually escapes as sunlight and solar wind. Understanding this composition isn't just about curiosity. It helps us predict space weather, protect satellites, and even plan future missions. After all, the solar wind isn't just empty space. It's a flowing record of our star's secrets, waiting to be decoded. Long before telescopes or satellites, ancient civilizations witnessed the solar wind's invisible handiwork, though they didn't know it. Take the Babylonians, who carved meticulous records of the heavens onto clay tablets over 2,600 years ago. Among their observations were strange red clouds dancing in the night sky, likely the auroras we know today. Halfway across the world, Chinese astronomers of the Han Dynasty described similar marvels, calling them celestial dragons or glowing vapors, their scribes noting these lights as omens from the heavens. These early sky watchers had no concept of charged particles or magnetic fields, yet their accounts align perfectly with modern science. When solar wind collides with Earth's atmosphere near the poles, it creates those very auroras they documented. The Norse, too, wove these shimmering displays into their myths, imagining them as the armor of Valkyries riding to Valhalla. Even indigenous peoples in North America told stories of ancestors lighting fires in the spirit world, their glow seen from below. What's remarkable is how these scattered cultures, separated by oceans and centuries, all bore witness to the same phenomenon. Without knowing it, they were chronicling the solar wind's impact, their poetry and prophecies capturing data that scientists now study with satellites. It's a reminder that the mysteries of space have always stirred human imagination. bridging the gap between ancient stargazers and modern explorers. And as we piece together their observations, we uncover not just the history of the solar wind, but the timeless human urge to understand the skies. Now, let's turn our attention to how modern science keeps a watchful eye on the solar wind's ever-changing behavior. Today, agencies like the National Oceanic and Atmospheric Administration, or NOAA, continuously monitor these streams of charged particles from the sun. Using advanced satellites and ground-based instruments, they track solar wind's speed, density, and magnetic field direction in real time. This data isn't just for scientific curiosity. It powers vital space, weather forecasts that protect our technology-dependent world. For astronauts aboard the International Space Station, these forecasts are a matter of safety. Intense solar wind during storms can expose crew members to dangerous radiation levels, forcing them to take shelter in shielded areas. Airlines also rely on space weather alerts, especially for polar routes, where heightened radiation from solar activity can affect both passengers and aircraft systems. Pilots may adjust altitudes or flight paths based on these warnings, but the impact reaches far beyond aviation. Solar wind disturbances can disrupt satellite operations, knocking out GPS signals we depend on for navigation. They can induce powerful electrical currents in power grids, risking widespread blackouts like the one that left 6 million people in Quebec without electricity for 9 hours during a major solar storm in 1989. Even undersea internet cables aren't immune, as geomagnetic storms triggered by solar wind can degrade their signals. This constant vigilance reveals an extraordinary truth, that the gentle solar wind we've been following can transform into a celestial tempest with very earthly consequences. By predicting these space weather events, scientists help safeguard everything from your smartphone's navigation to the stability of national power networks, proving that understanding the sun's breath isn't just about exploring space, but about protecting life down here on Earth. Now, let's explore the rhythmic heartbeat of our sun, the remarkable 11-year cycle that governs its activity. Like a cosmic pendulum, the sun swings between periods of calm and intense storms, shaping the behavior of solar wind in predictable yet dramatic ways. During what scientists call solar maximum, the sun becomes incredibly active, with sunspots peppering its surface and frequent eruptions launching stronger, faster streams of charged particles into space. These turbulent periods can last for several years, filling the solar system with unpredictable bursts of energy. Then comes the solar minimum, when the sun quiets down, its surface appearing almost spotless. Solar wind during this phase tends to be slower and steadier, though still capable of surprises. This cycle isn't just a scientific curiosity, it directly impacts how we explore space. Missions planned during solar maximum face greater risks from radiation and solar storms, forcing engineers to design spacecraft with extra shielding. Astronauts on future Moon or Mars missions will need to time their journeys carefully, avoiding peak solar activity that could expose them to dangerous particle flows. Even robotic explorers feel the effects. Satellites in Earth's orbit experience increased drag during solar maximum as our atmosphere expands in response to the sun's heightened energy output. Meanwhile, missions studying other planets must account for shifts in solar wind intensity that could affect communication signals or instrument readings. Understanding this cycle isn't just about predicting space weather, it's about unlocking the perfect windows for exploration when the sun's breath is neither too gentle nor too fierce. As we stand on the brink of new voyages beyond Earth, decoding this celestial rhythm becomes ever more vital for safe passage through our stars' changing moods. Now, let's turn our gaze beyond Earth and see how the solar wind dances with other worlds in our cosmic neighborhood. Each planet tells a different story, shaped by its unique relationship with the sun's charged particles. Take Mars, for example, a world that once had flowing water, but now stands exposed to the solar wind's full force. Without a strong global magnetic field to shield it, the solar wind has slowly stripped away much of Mars' atmosphere over billions of years, leaving behind the thin, cold desert we see today. Scientists believe this relentless erosion played a key role in transforming Mars from a potentially habitable world into the barren landscape we know now. Then there's Jupiter, the solar system's giant, where the solar wind meets a magnetic field so powerful it could swallow Earth whole. Jupiter's magnetosphere acts like a cosmic fortress, deflecting and trapping solar wind particles with ease. But when those particles do slip through, they ignite auroras so vast and bright they could outshine the sun itself. These dazzling light shows aren't just beautiful, they reveal the intense energy exchanges happening high above Jupiter's stormy clouds. Even Jupiter's moons feel the solar wind's touch, with volcanic Io and icy Europa bathed in radiation from particles caught in the planet's magnetic grip. The contrast between these worlds couldn't be starker. Mars, vulnerable and weathered by the solar wind's steady assault, serves as a cautionary tale of what happens when a planet loses its protective shield. Jupiter, on the other hand, shows us how a mighty magnetic field can turn the solar wind into a spectacular cosmic display. These interactions remind us that the solar wind isn't just a backdrop to our solar system, it's an active sculptor, shaping planets and their destinies in ways we're only beginning to understand. But here's something that might surprise you. The solar wind doesn't slow down as it races away from the sun. Instead, it speeds up, and scientists are still unraveling this cosmic mystery. Picture a river flowing downstream, only to suddenly surge faster the farther it gets from its source. That's the puzzle of solar wind acceleration. One leading theory points to magnetic waves rippling through the sun's corona. These waves, generated by the sun's churning plasma, might transfer energy to the solar wind particles, giving them an extra push as they travel outward. Think of it like a surfer catching a wave. The particles ride these magnetic ripples, gaining speed across vast distances. Then there's the role of nanoflares, tiny but frequent explosions on the sun's surface. Unlike the massive solar flares we often hear about, nanoflares are minuscule, yet they could pack a collective punch. Some researchers believe these miniature bursts heat the corona and inject energy into the solar wind, helping it accelerate far beyond the sun's immediate grip. Yet, despite these clues, the full picture remains elusive. Why does the solar wind defy the expected slowdown? How do these mechanisms work together? Each new mission, like the Parker Solar Probe, brings us closer to answers, but the mystery endures, a reminder that even the sun's gentle breath holds secrets waiting to be uncovered. Now, let's turn our gaze from the sun's mysteries to its quiet but profound influence on our closest celestial neighbor, the moon. You might think of the lunar surface as barren and unchanging, but the solar wind has been silently shaping it for billions of years. As those charged particles from the sun bombard the moon's surface, they interact with minerals in the soil, implanting hydrogen ions deep into the dust. Over time, these particles combine with oxygen, atoms already present in the lunar rocks, forming tiny molecules of water. This discovery was a game changer. Scientists once believed the moon was bone dry, but missions like India's Chandrayaan-1 and NASA's Lunar Reconnaissance Orbiter revealed traces of water locked in the soil, especially near the poles. The solar wind, it turns out, has been a cosmic gardener, slowly sowing the seeds of water across the lunar landscape. What does this mean for the future? Water is more than just a resource. It's a lifeline for exploration. Future lunar bases could harvest this solar wind, generated water for drinking, growing plants, or even splitting it into hydrogen and oxygen for rocket fuel. Imagine a lunar outpost powered by the very particles the sun has been sending our way for eons. The moon's soil holds clues not just about our past, but about humanity's next giant leap. As we prepare to return to the moon, understanding the solar wind's role in creating these water molecules could be the key to unlocking a sustainable presence in space. The sun's breath, it seems, has been preparing the way all along. While the solar wind is invisible to our eyes, artists and filmmakers have found captivating ways to bring this cosmic phenomenon to life. Picture the swirling auroras in movies like The Day After Tomorrow, where the sky dances with eerie green light, a direct result of solar wind particles colliding with Earth's atmosphere. Sci-fi classics often use solar wind as a dramatic force, from the menacing solar flares in Sunshine to the shimmering plasma storms in Interstellar. These creative portrayals, though exaggerated, capture the raw power and beauty of the sun's invisible breath. Beyond Hollywood, scientists and digital artists collaborate to transform real solar wind data into stunning visuals. Spacecraft like SOHO and Stereo capture streams of charged particles as they race from the sun, and artists enhance these images with color and motion, turning raw numbers into cosmic masterpieces. Some even translate solar wind patterns into sound, creating haunting space music that lets us hear the sun's whispers. From ancient cave paintings of auroras to modern VR simulations, humanity has always sought to make the invisible tangible. These artistic interpretations do more than entertain. They help us grasp the grandeur of the solar wind, bridging the gap between science and the imagination. And as we'll see next, this creative spirit extends even further, with composers and sound designers turning solar wind data into an otherworldly symphony. Now let's tune into something truly extraordinary, the sound of the solar wind itself. Scientists have found a way to translate the streams of charged particles into audible frequencies, turning raw data into what can only be described as eerie space music. Imagine the solar wind's particles, electrons and protons, racing through the void, being transformed into a symphony of crackles, hums, and whistles. This process, known as sonification, takes the invisible and makes it something we can hear, revealing hidden rhythms and patterns in the sun's constant outflow. The technique works by assigning different pitches and tones to the speed, density, and magnetic fluctuations of the solar wind. Faster particles might become high-pitched whines, while denser streams create deeper, resonant pulses. The result is a haunting soundscape that feels almost alive, like the sun is whispering secrets across space. Some recordings even capture sudden bursts of noise, evidence of solar flares or magnetic storms shaking up the wind's flow. What's fascinating is how these sounds aren't just for curiosity. They help scientists detect subtle changes in the solar wind that might be missed in visual data. By listening, researchers can pick up on irregularities, like sudden shifts in particle density or the telltale signs of a coronal mass ejection. It's a reminder that the universe speaks in more ways than one, and sometimes the best way to understand it is to close our eyes and listen. And as this cosmic melody plays on, it invites us to wonder, what other secrets might the solar wind reveal if we keep listening? Now, let's turn our gaze beyond our solar system and consider how the solar wind might shape the story of life elsewhere in the cosmos. When we think about exoplanet, its worlds orbiting distant stars, the solar wind takes on a whole new role, one that could make or break their chances of hosting life. Picture a planet bathed in the relentless stream of charged particles from its star. On one hand, a gentle solar wind might deliver just enough energy to stir a planet's atmosphere, perhaps even helping to create the chemical building blocks for life. But on the other hand, a fierce, unyielding wind could slowly strip away that same atmosphere, leaving a barren rock behind. It's a delicate balance, and the difference between a habitable world and a lifeless one might come down to the strength of that invisible cosmic breeze. Take Mars, for example. Scientists believe it once had a thicker atmosphere and even liquid water, but over billions of years, the solar wind may have eroded much of its air, leaving it the cold, dry desert we see today. Now imagine that same process playing out on exoplanets around active stars. Some might lose their protective blankets entirely, while others, with just the right magnetic fields or atmospheric chemistry, could hold on tight and nurture life beneath their skies. And here's another twist. What if the solar wind doesn't just take away, but also gives? Some researchers speculate that charged particles could deliver energy to the surface of icy moons or planets, sparking chemical reactions in underground oceans, or even providing a steady source of nourishment for hardy microbes. It's a reminder that life, if it's out there, might find ways to thrive in the unlikeliest of places, turning the solar wind from a destroyer into a silent partner. So as we search for signs of life beyond Earth, the solar wind reminds us that habitability isn't just about distance from a star or the presence of water. It's about the invisible forces that shape worlds, both gently and violently, across the galaxy. But the story of the solar wind doesn't end here. As we peer into the future, new missions are gearing up to uncover even deeper secrets of this cosmic phenomenon. Leading the charge is the European Space Agency's Solar Orbiter, a spacecraft designed to do what no other has done before: study the sun's mysterious poles up close. Why the poles? Because this is where some of the solar wind's most puzzling behaviors originate. The solar orbiter will capture never before seen images and data, helping scientists understand how the sun's magnetic fields twist and turn at these high latitudes, shaping the wind that flows outward. It's like getting a front row seat to the sun's hidden dance, one that could rewrite what we know about space weather. And this mission isn't alone. NASA's upcoming projects, like the interstellar mapping and acceleration probe, will focus on how the solar wind interacts with the very edge of our solar system, where it meets the vastness of interstellar space. Together, these missions promise to peel back another layer of the solar wind's mysteries, from its explosive beginnings to its far-reaching effects. What's truly exciting is that each discovery could ripple across astronomy, space travel, and even our understanding of life's potential beyond Earth. The solar wind isn't just a stream of particles, it's a key to unlocking the sun's deepest secrets, and soon we'll have a whole new set of tools to decode its message. Long before telescopes or satellites, our ancestors looked to the skies and wove stories to explain the shimmering lights and unseen forces dancing above them. The solar wind, though invisible to the naked eye, left its mark in the legends of cultures across the world. Take the Norse, for example, who believed the auroras were the gleaming armor of the Valkyries, warrior maidens who carried fallen heroes to the afterlife. To them, those rippling curtains of light weren't just beautiful. They were a bridge between worlds, a celestial spectacle charged with meaning. Indigenous peoples of the Arctic had their own interpretations. The Inuit saw the auroras as spirits playing ball with a walrus skull, while the Sami believed the lights were the energy of departed souls. These stories, passed down through generations, were more than just folklore. They were early attempts to make sense of the solar wind's effects, long before science revealed the truth. Even in ancient China, records describe celestial dragons breathing fire across the heavens, possibly referencing the same geomagnetic storms we study today. What's fascinating is how these myths, though separated by continents and centuries, all point to a shared human instinct to find wonder in the unknown. Now, with modern science, we've replaced dragons and valkyries with protons and magnetic fields, but the awe remains. The solar wind, once the stuff of legend, is now a story we're still writing, one discovery at a time. Now, let's step back and see the bigger picture, how the solar wind fits into the grand tapestry of the cosmos. This stream of charged particles isn't just a local phenomenon, it's part of a universal process that shapes galaxies over billions of years. Stars like our Sun constantly shed material through stellar winds, carrying elements forged in their cores out into the void. These winds act as cosmic delivery systems, scattering heavier elements like carbon, oxygen, and iron across interstellar space. Over time, these recycled materials become the building blocks for new stars, planets, and even life itself. Think of it like a celestial relay race. When massive stars reach the end of their lives and explode as supernova, their winds and shock waves inject even more enriched material into the galaxy. The solar wind, though gentler, plays its part by continuously seeding nearby space with particles that may one day be incorporated into future cosmic structures. Without this process, the universe would lack the diversity of elements essential for everything from rocky planets to DNA, but the influence doesn't stop there. Stellar winds also help regulate the birth of new stars. By clearing away excess gas and dust, they prevent regions like nebulae from collapsing too quickly, pacing the formation of stellar nurseries. It's a delicate balance. Too much wind can stifle star formation, while too little leaves material stagnant. Our sun's wind, along with those of countless other stars, quietly orchestrates this dance of creation and dispersal across the galaxy. So the next time you feel a breeze on Earth, remember, it's a tiny echo of the solar wind's grander role, a force that not only connects us to the sun, but also weaves the story of the universe itself. Now, here's something truly special. You don't need a spacecraft or a fancy lab to experience the solar wind firsthand. Its effects are all around us, waiting to be noticed if you know where to look. One of the most breathtaking ways to witness its power is by watching the auroras, those shimmering curtains of light dancing near the Earth's poles. When charged particles from the solar wind collide with our atmosphere, they create these dazzling displays of greens, pinks, and purples. It's like catching a glimpse of the sun's breath, painting the night sky. If you're not near the polar regions, don't worry, technology brings the solar wind to you. Websites and apps from agencies like NOAA provide real-time space weather alerts, tracking solar wind speed and density. When a strong gust is headed our way, you'll know to keep an eye out for auroras or even subtle changes in radio signals, which the solar wind can disrupt. It's a reminder that this invisible stream connects us all, no matter where we are on the planet. For the more hands-on observers, amateur radio operators often detect solar wind's influence firsthand. Sudden shifts in signal strength or unusual static can signal a surge in particle activity. Even your smartphone can play a part. Apps that visualize space weather let you track the solar wind's ebb and flow, like checking the daily forecast. Suddenly, this vast cosmic phenomenon feels as close as the air we breathe. So whether you're gazing at the northern lights or refreshing a space weather feed, you're joining a long tradition of humans marveling at the sun's invisible hand. The solar wind isn't just a scientific curiosity. It's a living, dynamic force we can all experience if we just take a moment to look up. Now, let's turn our gaze toward the future, where the solar wind isn't just a force to observe, but one we might actually ride. Imagine spacecraft gliding through the cosmos, not with roaring engines, but on the gentle push of the sun's own breath. This isn't science fiction. Solar sails, thin and lightweight yet vast in size, could harness the steady pressure of solar wind particles to propel missions farther and faster than traditional fuel allows. Picture a sailboat catching the wind, but instead of fabric billowing in a breeze, these sails are made of ultra-thin, reflective material, designed to catch the momentum of charged particles streaming from the sun. Even though the solar wind's pressure is faint, about the weight of a paper clip resting on your palm, in the frictionless void of space, that tiny push adds up over time. With no resistance to slow it down, a solar sail could reach astonishing speeds, carrying probes to the outer planets or even beyond our solar system. Already, we've seen glimpses of this technology in action. Missions like Japan's Ikaros and NASA NanoSail-D have successfully tested solar sails in space, unfurling their shimmering sheets to catch not just solar wind, but even the pressure of sunlight itself. The results are promising, hinting at a future where interstellar travel could be powered by the very star we orbit. What's truly exciting is how solar sails could revolutionize exploration. Without the need for heavy fuel tanks, spacecraft could be lighter, cheaper, and capable of journeys lasting decades. Imagine a fleet of sails drifting toward Alpha Centauri or skimming the edges of distant comets, all propelled by the same cosmic wind that paints our auroras. It's a reminder that the sun's influence doesn't just shape our skies, it might one day carry us to the stars. Now, let's take a closer look at how the study of solar wind isn't just about space weather. It's also pushing the boundaries of quantum physics. The solar wind is essentially a sea of charged particles, a superheated plasma that behaves in ways that challenge our understanding of matter and energy. By observing how these particles move and interact, scientists are uncovering secrets about plasma physics, a field that bridges the gap between the tiny world of quantum mechanics and the vastness of space. One of the most fascinating puzzles is how particles in the solar wind accelerate to such incredible speeds. Traditional physics suggests they should slow down as they move away from the sun, yet the opposite happens. This mystery has led researchers to explore quantum-scale phenomena like magnetic reconnection and wave-particle interactions, where energy is transferred in ways that defy classical expectations. These discoveries aren't just academic. They could revolutionize technologies like fusion energy, where controlling plasma is the key to unlocking clean, limitless power. The solar wind also acts as a natural laboratory for studying particle behavior in extreme conditions. Unlike experiments on Earth, which are limited by lab equipment, the solar wind offers a real-time glimpse into how particles behave in the vacuum of space, under the influence of the sun's immense magnetic fields. This data helps refine quantum models, offering clues about how energy is distributed and transformed on the smallest scales. What's truly remarkable is how these insights ripple across science. From improving satellite shielding to advancing medical radiation therapies, the lessons learned from solar wind research are proving invaluable. It's a reminder that the sun's influence stretches far beyond light and heat. It's helping us decode the fundamental laws of the universe itself. Now, let's shift our gaze from the science labs to the silver screen, where the solar wind has inspired artists and storytellers for decades. One of the most iconic nods comes from David Bowie's Space Oddity, where Major Tom drifts helplessly in space, carried by the solar winds that symbolize both the beauty and isolation of the cosmos. Bowie's haunting lyrics capture the eerie, untamed nature of this celestial force, blending science with poetry. Science fiction has also embraced the solar wind as a plot device. In Star Trek, starships often navigate through solar plasma storms, a dramatic take on the real-life turbulence caused by charged particles. These stories amplify the solar wind's mystique, turning it into a backdrop for adventure or danger. Even in the expanse, the solar wind's effects on spacecraft and colonies add a layer of realism to the show's futuristic setting. Literature isn't far behind. Authors like Arthur C. Clarke and Kim Stanley Robinson weave the solar wind into their narratives, using it as a metaphor for humanity's fragile place in the universe. In 2010, Odyssey 2, Clarke describes how the solar wind sculpts Jupiter's magnetosphere, grounding his fiction in real astrophysics. Meanwhile, Robinson's Red Mars imagines colonists harnessing solar wind for energy, blurring the line between science and speculation. Even video games like Elite Dangerous and No Man's Sky let players pilot ships through solar winds, making this cosmic phenomenon interactive. These creative interpretations don't just entertain, they spark curiosity, inviting audiences to explore the real science behind the stories. Whether in music, film, or games, the solar wind's cultural footprint reminds us that the universe isn't just a subject for textbooks. It's a canvas for imagination, connecting the dots between what we know and what we dream. Now, let's take a moment to slow down and immerse ourselves in the gentle flow of the solar wind. Close your eyes if you'd like, and picture yourself drifting effortlessly through space, surrounded by a shimmering stream of charged particles. These tiny specks of energy, born from the sun's fiery heart, brush against you like a cosmic breeze, carrying warmth and light across the vast emptiness. Feel the rhythm of their movement, swift yet soothing, as they dance around you. Some race ahead at nearly 800 kilometers per second, while others meander more slowly, creating a delicate symphony of motion. Imagine their glow, soft and golden, like sunlight filtering through leaves, as they weave through the darkness, connecting you to the distant, radiant star that gave them life. With each breath, let yourself sink with this celestial current. Picture the sun's magnetic fields guiding these particles, twisting and turning like invisible ribbons, and know that you're part of this grand, invisible dance. The solar wind isn't just a force of nature. It's a reminder that even in the quietest corners of space, there's energy, connection, and a beauty that transcends time. As you float here, weightless and serene, let the solar wind's gentle push lull you into a deeper calm. It's a whisper from the universe itself, inviting you to rest, to dream, and to marvel at the wonders that flow unseen around us all. As we come to the close of our journey through the mysteries of the solar wind, let's take one last moment to reflect on its incredible story. From its fiery birth in the sun's corona, where temperatures soar beyond imagination, to its endless voyage across the solar system, this stream of charged particles connects us all to the heart of our star. It shapes the space around planets, paints the sky with auroras, and even whispers secrets about the universe's grand design. Think of how this invisible force, born from the sun's restless energy, travels billions of kilometers to touch Earth, gently shaping our world in ways we're only beginning to understand. It's a reminder that even in the vast silence of space, there's motion, there's life, and there's a delicate balance that keeps our cosmic neighborhood alive. Now, as you settle into stillness, let the image of the solar wind linger in your mind, a golden river of particles, flowing endlessly from the sun, wrapping the planets in its embrace. Picture yourself floating within it, carried by its gentle current, as the universe hums its quiet lullaby. Close your eyes, breathe deeply, and let the wonder of this cosmic breeze guide you into peaceful rest. The sun's breath is always with us, a timeless reminder of the beauty and mystery that surrounds us, even in the darkest night. If you enjoyed this journey through the stars, don't forget to subscribe for more sleep stories and cosmic explorations. Hit the like button if you found it soothing, and ring the notification bell so you never miss an adventure into the universe's wonders. Sweet dreams, and may the solar wind carry you gently into the night.